Hi class, welcome to lesson 4 of unit 1. Today we're going to focus on calculating density. This is something you probably have done since middle school. As we apply the density formula, we'll be able to calculate mass, volume, and density. After we apply the formula, we will be able to evaluate the accuracy of our calculation using a percent error. Density is described as the relationship between mass and volume. So mass is the amount of matter, or atoms, in a substance. It is related to both the type and number of atoms present. We measure mass with a balance. Volume is the amount of space a substance occupies. One way to measure volume is to use an instrument here called a burette or a graduated cylinder. There are a number of ways we can measure volume. When we have rectangular objects, we can apply volume formulas. For instance, the volume of a rectangular prism is the length times the width times the height. Now, for irregular objects, gases, and liquids, we use a graduated cylinder to measure the volume. The units of a graduated cylinder are typically 1 milliliter, which is the same as 1 cubic centimeter. So if you made a cube that was 1 centimeter by 1 centimeter by 1 centimeter, and you filled it with water, that cube would hold exactly 1 milliliter. Now, in the medical field, we often call the cubic centimeter a cc. So these units are interchangeable. They are the same. Recall that when measuring volume, you must always measure the volume of a graduated cylinder at eye level and read to the bottom of the meniscus. To record the volume of an irregular object, begin by filling your graduated cylinder to a known volume. Add the object and measure the amount of displacement, or the difference in the water level. The amount of change in the water level is the same as the volume of the object. You'll find the density formula here on reference table T. So density is the ratio of mass per volume. Notice these red particles occupy the same volume, but the box on the left is less dense because there is less mass, less particles in the same volume as the box to the right. In the boxes below, with the green particles, each box contains 5 particles. Each box has the same mass. Here, the volume differs. So we can see that the box to the left is more dense because it has the same number of particles in a smaller volume. Let's try and solve this problem together. The first step we should do is write out our density formula. I like to make a table of variables. Read through the question, I'll identify the numbers given and what variable they correspond with. So we begin with the density of mercury is 13.6 gram per cubic centimeter. So my density is 13.6. And it asks us what is the mass of 95 milliliters. Milliliters is a volume. In every single equation in chemistry, you have to identify one unknown, or 1x. In this case, our unknown is the mass. Now I can create a substitution. The final step is to solve this algebraically. Since we have a fraction on one side and no fraction on the other, you may find it easiest to place the whole number over 1 to turn it into a fraction. This will allow you to solve by cross multiplication. Now that we have a calculator answer, Our final step would be to write our number to the proper number of significant digits. Here we use multiplication and division, which means our answer should have no more significant figures than the measurements in our question. 13.6 has 3 digits and 95 has 2. So our answer should only have 2 significant digits. What we should do is underline the first 2 significant digits and circle the third so we can understand how we are going to round. (1,300 grams) is our answer rounded to the proper number of significant digits. Significant digits are really important, particularly in multiple choice questions, as all answers in multiple choice questions are rounded to the proper number of significant digits. Let's try to apply the same problem-solving technique to the next example. So we'll begin by writing out our density formula. And we'll make a variable table. As we read the question, we'll identify the variables given. So here we're looking for the density of 50 grams. That's mass. And we see that we have a volume of 2.22. Here our calculator gives us a very long answer, but we must round to the proper number of significant digits. 50 grams as written has 4 significant digits. 2.22 has 3 significant digits, so we'll want to round our answer to 3 significant digits. We will underline the first 3 digits and examine the 4th digit to determine how we round. So here we're going to end up with a density of 22.5 grams per cubic centimeter. You could even write this as grams per milliliter.
My name's Sydney. I'm Miss Lytle's daughter. Now, let's work on one more problem for today. Let's calculate the volume of a 10-gram piece of iron. Hi. Okay, now let's fill in the variables. So, we know that M equals mass, and we have 10 grams. But that's all the information we have, so we can't figure out anything else. What could I possibly do? Oh wait! I have my reference table! Oh wait! Okay, so here is iron, and its density is 7.87.
Yes.
Okay, now you substitute and solve.
Look at percent error. Percent error is another equation found on reference table T, the back of your reference table. You do not need to memorize this equation. You simply need to know how to use it. From the equation, you can see that we must determine a measured value and an accepted value. When we say accepted value, we mean the value that is either found on a reference table or the value that is expected due to a calculation. The measured value is a value that's typically found in lab. When you find percent error, it could be either positive or negative. A positive percent error means that your value is more than the expected or the accepted value. A negative percent error means your measured value is less than the accepted value. Try your hand at a few of these sample questions. This is the end of the video for Lesson 4, Unit 1. See you in class.